In this lesson, we will continue our discussion on different calculations that we can do using the for loop. We have seen the use of count, sum and the product calculation using the for loop. Now we will see the case where we can use the for loop to indicate if something happened or not. We can use a variable as a flag variable to indicate that. Flag variable is not a programming term. I'm calling it as a flag variable because when a particular event will happen, this variable will indicate that by changing its value. Let me explain that with a very simple example. Suppose we are taking 10 numbers from the user and we have to just indicate if user entered 100 or not. We don't want to count the number of hundreds user has entered. We just want to indicate if the 100 was entered by the user or not. So as we did before, suppose these are the 10 numbers entered by the user and we have to develop the logic that it contains 100 or not. The logic is very similar to what we did in case of counting some event. So I'm hiding all numbers and I have a variable named as flag and the value is 0. Remember, it's not the count. It's just indicating that we haven't seen 100 entered by the user. So we will scan the numbers one by one. If we don't see 100, we will not change the value of flag variable. And now there is 100, so I should change the value of flag variable to some other value. The simplest can be changing it to 1. Now the next value is not 100, so it doesn't mean that I should change back the value of flag variable to 0. And even if it was 100, even in that case I will not change the value of this flag variable. Like now we have next number as 100, but the value of flag variable will remain as 1. So what it means is that once we have detected the event, we will change the value of the flag variable, and after that we will not change that value in any case. So the overall effect of this algorithm is that after the whole scan, if the value of the flag variable is 0 which was initially set, that would mean that there was not 100 entered by the user. And if the value of flag variable is changed to 1, it means there was at least 100 entered by the user. So let's see that first in the coding, and then we will see a couple of practical examples where we will be using this approach. So I'm writing the for loop to take in 10 values from the user. Now I should declare a flag variable before the start of the for loop. It can have any name, for example check, and I will set its value to 0. Now inside the for loop I will apply a check if that number entered by the user is 100 or not, and if it is 100 I will change the value of the variable check to some other value, for example 1. Now outside the for loop I can apply a condition on the flag variable which is check over here, that if it is equal to 1 then it means that the condition on line number 4 was true for at least one time during the iteration of the for loop. So that means 100 was entered by the user. So I can have a simple display message over there. And else means the value of check is not 1, meaning that it would be 0. So I can have the other message that 100 was not entered by the user. I'm entering the values. I have entered 100 3 times and you can see the respective display message. You should run this code in step-by-step mode to see the working sequence of this program. Now let's discuss this flag variable in detail. I assigned it some value which for this case is 0, and when the condition which we were looking for is true, I assigned a different value to it which is 1. But instead of 0 and 1 we can have any value. Maybe we can assign the value as 500 before the start of the for loop, and when the condition is true we can assign some other value, for example 1000, and then outside the for loop we can check if it is 500 or 1000 to decide whether the event occurred or not. But of course that will not be a good approach. The simplest can be using a 0 before the for loop and 1 when the condition is true. So this is a case where we know that this variable can have only 2 possible values. So you should easily figure out that we can better use some Boolean variable over here. So what I can do is, before the start of the for loop I can assign the value of check variable as false, and then on line number 5 when the condition is true I can assign true to check variable. I don't need to change anything on this condition because 1 and true are same. So this check equal to 1 will be true when check is having the value true. But there is even a better way, that instead of comparing the value of check variable to 1 or true, I can simply have this variable name inside the if condition. Now this might look strange to you, but remember when we studied about the condition, we said that every condition is evaluated and the result is either true or false. So whenever we have a condition inside the if statement, that condition would return either true or false. If it returns true, that means if block will get executed. And if it returns false, it means if block will not get executed, and if there is else block, that will get executed. Over here, our check variable is a Boolean variable and it will have either true or false. So when I'm saying that if check, this condition will be true when the value of the check variable is true, and the condition will be false when the value of check variable is false. Let's check that by running the code. And this time I'm not entering any 100. And you can see the correct output. Now before I move to some other task where we would need to use these flag variables or the check variables, I will first discuss about the case where we can have a Boolean variable as the return value of a function. So I'm creating a very simple function with the name isEven. It will have one number as the input argument, and this function will determine if the n is even or not. And the result should be true or false. True means n is even and false means n is not even. So I can apply a check if the n is even and I can return 1 over there, and else means n is not even and I can return 0. Now this name isEven is also indicating that the function is going to determine if the value is even or not, and instead of 1 and 0, it would be better to use true and false. Now this is a function which has a Boolean value as its return value. Now let's see how we can use it in the main program. For example, I'm taking the number from the user, and then I will apply the if condition, and I will call this function isEven on the entered value by the user. Now I know that the function would be returning either true or false, so I don't need to apply any equality check over there. This isEven num will get evaluated as true or false. I know it is a very simple case. The only purpose was to show you a case where we can have a Boolean value as the return value of the function. We will have a better example in a while. There is one more thing I would like to indicate over here. In this function, I can remove this else block and can simply return false but outside the if block statement. Some of you might be thinking that it will always return false because that is the last statement of this particular function. But that's not true. The logic is correct. If the n is even and the condition on line number 2 will be true, and that will execute this return true on line number 3. In a function, whenever return statement is executed, the interpreter moves to the line where the function was called, for example on line number 7, and will return that value over there. So in that case, line number 4 will not get executed. And if n is odd, it means the condition on line number 2 is false. Interpreter will not enter into the block of the if statement which is on line number 3, and it will execute line number 4 which is return false. So there is no problem in this logic. Let's verify it for an even number, and you can see the result is correct. If I have this kind of a logic where I am assigning the value of true or false to a variable, for example c, and then at the end I am returning the variable c, now I cannot remove this else block. Like this. In this case, every time false will be returned by the function. So I hope this idea is clear. So now let's do a task where we will be taking a number from the user and we will display if the entered number is a prime number or not. We know that a prime number is a number which has only two factors. The first is 1 and the second is the number itself. Or in other words, we can say that there is no factor from 2 to number minus 1. For example, 19 is a prime number because there is no factor of 19 from 2 to 18. And 20 is not a prime number, also known as composite number, because we have factors for 20 other than 1 and 20 itself. For example, 2 is factor of 20, 4 is factor of 20, which makes 20 as composite number. So that is what we have to do in this task. We will suppose that user will enter a positive integer. So what can be the logic to determine this? Suppose user has entered 19. So what we need to do is we need to see if it has factors from 2 to 18 or not. So this 2 to 18 is indicating that we have to use a for loop which will generate these numbers. And what we need to do in the for loop, we need to see if there is a factor of 19 or not. We don't need how many factors are there. We simply need to know if there is any factor or not. And that indicates that we have to use kind of flag variables. So if the entered integer is stored in the variable num, I have to generate the numbers from 2 to num minus 1. So I can have a for loop, and inside the range function, I will specify the start integer as 2 and the stop integer as num. And we know that the stop integer is not included in this range. So the numbers generated will be from 2 to num minus 1. The loop variable I will have those numbers in different iterations. So I need to check if I is a factor of entered value or not. So I should use the remainder division on num by I. And if it is 0, it means I is the factor of num. But to indicate that, I should have a flag variable before the start of the for loop. I'm setting its value as true. I'll tell you in a while why I'm setting the starting value as true instead of false. Now we have this condition that if remainder is 0, which means that I is the factor of num, and that means the condition of not being a prime number is satisfied. So I will change the value of flag variable to false because I want to determine if num is prime or not, and getting a factor means that it is not a prime number. So that is why on this condition I'm setting the value of check variable to false and the starting value of the check variable is true, which means that if the condition on line number 4 will be false in all iterations of the for loop, the value of check variable outside the for loop will be true, and that means the number is a prime number. So outside the for loop I can say if check, it means the entered number is a prime number. And else the entered number is not a prime number. Sorry, I did a mistake on line number 1. Instead of val, it should be input. Let's enter 21, which is not a prime number, and you can see the correct result. Now this time let's enter 23, which is a prime number, and we have again the correct result. Now let's discuss about the efficiency of this code. We are running this for loop from 2 to num minus 1. If num is having 100, this range function will generate numbers from 2 to 99. So can we reduce the number of iterations and of course with the correct results? The logic of prime number says that there is no factor from 2 to enter number minus 1, and that's why we have these values in the range function. But tell me, what is the maximum possible factor for any number? It shouldn't be difficult for you to figure out that the maximum factor for any number will be half of that number. For example, if the number is 100, the highest factor of 100 is 50. If the number is 500, the highest factor of 500 is 250. So instead of running the loop from 2 to num minus 1, I should run it from 2 to num by 2, and that is going to save half iterations and giving the exactly same result. So I will make it num by 2, but if num is an odd number, for example 99, this num by 2 will be a floating value, and that will generate an error for the range function. So I should convert this to an integer, and then I should also add +1 because now I have to include that half of the number in this range. Let's enter 97, which is a prime number, and the result is correct. And now let's enter 40, which is not a prime number, and the result is again correct. So we improved the code efficiency by saving half of the iterations. You can verify that by running the code in step-by-step mode. There is still possibility of further improvement in the logic of this particular program. To be a good programmer, the first goal is to have the solution of the problem, but then you should think about some better ways of doing the same thing. The code efficiency is one very important factor to be a good programmer. So let's see how we can further improve this code. Talking about the factors of a number, understand this statement. It says that if there exists no factor till the square root of a number, there will not be any after that. Remember, the reverse is not true. Read this carefully, that if there is no factor until the square root of a number, then there won't be any after that. Now let me tell you how this is possible. We will take the example of 100. These are the numbers from 1 to 100. We know the square root of 100 is 10, so I have divided these numbers into two groups. The first group is the numbers less than or equal to the square root of 100, and then this lower group is the numbers which are greater than the square root of that number. Now if there is any factor in the first group, there will be a corresponding factor in the second group. For example, we know that 1 is the factor of 100, but then 100 is also a factor of 100. Then if you say that 2 is a factor of 100, then on the lower group 50 is also the factor of 100. And these 2 and 50 are the factors of 100 because 2 times 50 is 100. So for any factor before the square root of a number, there will always be a factor after the square root of a number. If 4 is the factor of 100, 4 times 25 is 100, so 25 is also the factor of 100. If 5 is factor of 100, 5 times 20 is 100, so 20 is also the factor of 100. And eventually for this case, this 10 is the factor of 100, and 10 times 10 is 100, so 10 again, which is same as 10, is factor of 100. So what you can see from here, that the factor of any number exists in pairs. The first value of that pair is before the square root and the second value is after the square root. So if we don't have any factor before the square root of a number, that obviously means that there won't be any factor after the square root. So that's how we can improve the efficiency of this code. So I will import the square root function of the math module. And now instead of num by 2, I will specify the stop variable as square root of num. This conversion to integer is again needed, and then there should be also +1 so that the square root is also part of that range. Now let's test that. 97 is a prime number and 100 is not a prime number. So in case of 100, this for loop was executed from 2 to 10, meaning that there were only 9 iterations of this for loop and we got the correct result. Now can we have further improvement in the efficiency of this code? Let's again talk about 100 when we were scanning the number starting from 2, and when we see that 2 is a factor of 100, don't you think that the decision has been made over here? If 2 is a factor of 100, that means 100 is not a prime number. So these iterations from 2 to 10 can also be further improved by using a statement which is known as a break statement, which can break the iterations of the for loop. But I will have a separate video on different control statements of the loop, so I will not discuss that over here. Now let's do this task by creating a user-defined function similar to this isEven function, meaning that we have to create a function isPrime which will determine if the input argument is a prime or not. So I'm just changing the name of the function over here. Now let's see what can be the logic of this function. I will copy the logic from the previous program. Now I should return the check variable over here, which will be true if the number is prime and it will be false if the number is not a prime. Let's first verify that. Now there is one very important thing we can improve in this function. On line number 6, instead of assigning false to check variable, we can directly return the false. Because if we have found a factor, it means that a number is not a prime number and we can directly return the false. And you should get this idea that the interpreter will move from this point to the point where the function was called. And outside the for loop, I can return true, which means that no factor was found during the for loop. Now I don't need this check variable, and the good thing over here is that because of this line number 5, whenever there would be a factor, this function would return false, which means that it will skip the rest of the for loop and will simply return false to the point where the function was called. So in case of 100, in the first iteration of the for loop, when I is having the value 2, the condition will be true and false will be returned by the function. So in just one iteration, we will be able to determine that 100 is not a prime number. Let's verify that. I'm placing the breakpoint on line number 8. Let's enter 100. Interpreter is on line number 9 where we are calling the function isPrime. It will enter into the block of the function. The for loop variable I will get the first value 2, and now this condition is true for 102. So it will move to line number 5 and it has returned false over there. So it will return from this point to line number 9 where the function was called. So you can see that in just one iteration we have determined that 100 is not a prime number. So here is the summary of different approaches that we use to determine if a number is a prime number or not. In first approach, we had iterations from 2 to num minus 1. So if num is 100, it means the iterations will be from 2 to 99, meaning that there will be total 98 iterations. In second approach, we said that the maximum factor of any number will be num by 2. So we change the stop value of that range function to num by 2 plus 1, and in case of 100, it will be from 2 to 50, which means that there will be 49 iterations. Then we further improved this code and we said that we should check until the square root of that number. So in case of 100, it was from 2 to 10, meaning that there were total 9 iterations for this case. Finally, in the fourth approach, we did this by creating a user-defined function, and because of this return statement, the iteration where we will get a factor will be the last iteration of the for loop. So in case of 100, it would be just one iteration. So that's all from this lesson. Thanks for watching.